How did Iran manage to hit an American F-35 stealth fighter? Well, in modern warfare, there are primarily two kinds of anti-aircraft missiles: radar-guided and heat-seeking. The F-35 was designed to be practically invisible to long-range radar, but it wasn't built to completely hide from heat-seeking missiles. So how exactly did Iran missile manage to bypass the stealth technology of the US F-35? Well, the secret lies in a major vulnerability that is its heat signature. Its geometry and radar-absorbent materials make its radar cross-section incredibly small, essentially rendering it invisible to traditional early warning and targeting radars. To give you some context, this is how a plane's radar signature compares to a bird's. But the F-35 is powered by a single Pratt & Whitney F135 engine, one of the most powerful fighter engines in the world. The F-35 is heavily optimized to defeat radio frequency radar like the billion-dollar S-400 and S-300 missiles. However, stealth does not mean completely invisible. This engine produces a massive heat plume. Instead of using radar, modern air defense networks utilize infrared search and track systems. The answer is this short-range heat-seeking missile like this one. These passive sensors scan the skies for any heat anomalies. Because infrared search and track systems emit no energy themselves, the F-35's radar warning receivers would not alert the pilot that they were being painted by a target lock in the same way a radar lock would. But how did the missile lock, and how did the F-35 use evasive maneuvers? Once an infrared-guided missile is launched, the dynamic of the engagement changes to a race of physics and countermeasures. When the missile's IR seeker head locks onto the massive thermal output of the F-35's engine exhaust. But the detection, the F-35 is equipped with a distributed aperture system, 6 infrared cameras positioned around the aircraft that provide a 360-degree spherical view. The distributed aperture system detects the intense heat signature of the incoming missile's rocket motor and instantly alerts the pilot. To break the lock, the pilot executes high-G evasive maneuvers while simultaneously deploying flares. If the missile tracks the flares but is already within a lethal radius, its proximity fuse will trigger the warhead. The resulting shrapnel and shockwave can cause significant damage to the aircraft's control surfaces, stealth coating, or internal systems without scoring a catastrophic direct hit, which perfectly aligns with reports of the F-35 sustaining damage but safely executing an emergency landing. But what are flares? These pyrotechnic countermeasures are made of magnesium or other combustible metals that burn at temperatures exceeding the aircraft's engine heat. The goal of the flares is to overwhelm or confuse the missile's IR seeker, forcing it to chase the decoy heat sources instead of the jet. But what is Iran's secret weapon? We believe it's the 358 anti-aircraft missile, or the SA-67. The 358 is a unique hybrid between a loitering munition or kamikaze drone and a surface-to-air missile. But how does it work? It flies at slower subsonic speeds and can loiter in a designated airspace in a figure-8 pattern until its optical and infrared sensors detect a target. If a 385 missile or a more advanced high-speed indigenous IR-guided surface-to-air missile was guided by a ground-based IRST network, it could engage the F-35 entirely within the infrared spectrum, bypassing the jet's radar-evading capabilities entirely. This incident challenges the long-held doctrine that fifth-generation fighters can operate with total impunity in contested airspace, highlighting the evolving threat of infrared detection. But it has its advantages as it cannot hit fighter jets far from its radius of launch system. During Operation Fury, the U.S. has been using F-35s to lead strikes and declared air superiority to hunt for surface-to-air missile and suppress air defenses. Although the U.S. has achieved near-total air superiority, but the war is just entering its most dangerous stage. But here is the problem: Iran is still not out of the fight. If the U.S. owns the sky, why not just send in standard fighters? Because while Iran's main network is shattered, isolated surface-to-air batteries like the S-300 are still hiding in the shadows. For an F-15E Strike Eagle, the legendary bomb truck of the Air Force, one lucky radar lock from a rogue missile is a death sentence. And in a high-stakes conflict, losing a crew and a multi-million-dollar jet to a surviving battery is a risk the Pentagon simply won't take. But how did the US and Israel manage to use F-35 jets to strike Iran while Iranian air defenses were still up and running? To make this happen, they didn't just rely on local land bases. They brought two massive floating cities right to Iran's doorstep. Down in the Arabian Sea, you've got the USS Abraham Lincoln Carrier Strike Group bearing down on the south and east. And over in the eastern Mediterranean, the biggest newest ship USS Gerald R. Ford. While Israeli jets flew all the way across the Middle East to reach Iranian airspace, timing was absolutely critical. The moment those IDF jets reached their marks, the missiles were released. And that brings us to the most terrifying, complicated part of this entire operation, the synchronization. Military planners rely on a tactic called time on target. Look at this map. You have missiles firing from submarines, cruise missiles launching from escort ships, and massive payload drops from stealth bombers. They are all deploying from completely different locations at entirely different times. But here is the genius of it. The US military machine was mathematically choreographed so everything impacted Kairaj, Tehran, Qom, Kermanshah, and Isfahan at the exact same second the Israeli jets dropped their guided bombs. It was designed to be a total systemic shock and explodes at the same time. A move to collapse the regime instantly. When those munitions finally hit, it was pure shock and awe. But why did the Iranian air defenses fail to activate? Well, to put it simply, the US military operates in a completely different league. Using a highly advanced mix of electronic warfare and cyber operations, coordinated from space to the ground, the coalition was able to inject false data directly into Iranian radar screens. Top-tier Iranian air defense systems, like their homegrown Bavar and their Russian-supplied batteries, were absolutely overwhelmed by this electronic assault.